All right, 8-7, we're going to look at radical function graphs. So we're going to graph them and then transform them. So radical functions, a function that has a radical expression. We looked at radical expressions yesterday. A square root function is a radical function that has the square root of x or the square root of some expression in the function definition. So the square root parent is just this. So we looked at parent functions. Linear parent functions is just f of x is equal to x. Quadratic f of x is equal to x squared. So square root function is just f of x is equal to square root of x. Cube root is f of x equals, and they have specific shapes. So we can't have a negative value underneath a square root function. So we're not going to have any values over in this part of the axis that's negative x. All right, so graph each function and identify its domain and range. Square root of x minus 3. Easiest thing to do for now is just to create a table of values. So here's our table. We can't have negative values, so our lowest value of x has to make it so that this is not negative. That means that our lowest value of x is going to be 3. Anything lower than 3 would be a negative square root, which is not real. So that's where they started. X equals 3 becomes the square root of 0, which is 0. So this is our ordered pair. When we've got 4, it becomes the square root of 1, which is 1. And then they went on to use values that make it easy. If x is 7, we have the square root of 4, which is 2. And when x is 12, we have the square root of 9, which is 3. So use values where you're going to get nice even integer values. Don't use, it's easier if you don't use values where you're going to end up with like 2.6 or something. So here are my values. Let me use a different color here. So 3, 0, 4, 1 is here, 7, 2, and so on, 12, 3. And that's the general shape. The parent function has its vertex, which is this point here, at 0, 0, and then goes in this direction. So most generally, they're going to look sort of like that. So what's the domain? Well, if we look at x is never going to be less than 3, so our domain is going to be x greater than or equal to 3. What's our range? Well, if we look at the graph, what's our lowest value of y? Y is never going to be less than 0 because the square root cannot be negative. So it's going to be y is greater than or equal to 0. Oops. Okay. Here's another example. This is the cube root. So again, make a table of values. Cubic functions can be negative, so we're going to start with some negative values, and again, it's easiest if you make it the values so that you turn out with some numbers that are easy to use. They started with negative 6, so we're going to have 2 times the cube root of negative 8. Cube root of negative 8 is negative 2, so 2 times negative 2 is negative 4. 1, they end up with 2 times the cube root of negative 1. Cube root of negative 1 is negative 1, so you have negative 2. And then cube root of 0. So here are your values. And if you graph it. So notice, if you remember, the cubic function looks like a squiggle. The cube root is a squiggle but sideways. Also, a quadratic function is a parabola. The radical, or the square root function, is half a parabola, and that's because we can't have negative values. So it might help you to kind of remember the shape. Sideways, they're kind of sideways graphs from the inverse exponential function. All right, so what is the domain and range? Do we see any restrictions on x or y? No. So if you can remember this, it makes it easy. For every cubic function, domain is all real numbers, range is all real numbers. This is for all cubic functions. So it's only square root or even index root functions that have restrictions. All right, so this is one for you to graph and identify its domain and range. Let's see. All right, now we're going to look at transformation. So we know the parent function. It looks like this. It starts at 0, 0, and then cube root of 1 is 1. So we're going to have a point at 1, 1. Then if we go to 4, or sorry, square root. If we go to 4, square root of 4 is 2. So we're going to have a point at 4, 2. And then we have to go all the way over to 9 to get to our next point. So that's what our parent function looks like. So transformation rules are exactly the same that we've seen all along. What's a vertical? If this is our parent function, a vertical transformation is just going to be plus k, where k is your vertical movement. Notice the k is outside of the square root function. So if k is positive, it moves up, k negative moves down. Horizontal, just like in quadratic and absolute value, horizontal, it's the opposite. So if we have a minus, we're going right. If we have a positive, we're going left. And notice it's within the function boundaries. It's underneath the radical sign. Vertical stretch, again, outside the function. So vertical stretch of 6 is 6 square root of x. Vertical stretch of, or compression of 1/2. So this is a compression, this is a stretch. And then likewise horizontal, inside the function, and it's reciprocal. So this is a horizontal stretch of 5. Notice it's 1/5 inside the square root sign. These are the same rules that we've had all along, so hopefully it'll make it easy. And then lastly, reflections. Vertical reflection or across the x-axis outside the square root sign, across the y-axis or horizontal reflection inside the square root sign. So that's a summary. Again, these are the same rules we've seen all along. Let's use, it says use the graph as a guide, describe the transformation, and graph the function. All right, so what rule is this? This is going to be our square root of x plus k. It's a vertical translation, 5 units up. And what I would do in this case, it's easy enough. So here, get my points. Here's my parent function, 0, 0, 4, 2, and where's 9, 3 is going to be right about, this must be 9 here, no, that's 10, right about here. So this is my parent. This is moved 5 units up. So I take my vertex, move it up to 5. I'm going to take 4 and go from 1 to 6. Oops, is that right? We moved up 5. So, oh, this is actually 2. So we're going to 7. So this goes up to, that's not right either. So 4, 2. We moved up 5. So we should go from 2 to 7. And somehow I'm not seeing that. I'm not sure where I went wrong. Here is 1, 1. So 1, 1 is going to go to 5 here. And 2 should go to 6. Where am I? Okay, what am I doing wrong here? So if I have, my parent is going to be x, y, 0, 1, 4, and 9, 0, 1, 2, 3, and my transformation plus 5. So this is going to go 5, 6, 7, 8. And I'm not sure. So 3 should be, oh, so 9 should be at 8. I guess that's an 8. That's where my problem is. This should be an 8, and I thought it was a 6. So anyway, those would be your new points. You would graph this, and you would be done with it. Okay, using the graph as a guide, you describe the transformation and graph the function. So here is your example. I would use a table of values because it's not as straightforward as horizontal and vertical translations. All right, so here is a summary of the rules. The square root, or a times the square root of 1 over b, x minus h plus k. So again, vertical stretch, horizontal stretch, horizontal shift, and vertical translation. And again, If you have a negative in front, it's going to be a reflection in front of your a or b. Okay, use the graph as a guide. Describe the transformation and graph the function. So here we have a negative. It's outside the square root, so we have a vertical reflection, which is a reflection over the x-axis. And then we're going right 4. So the way I would graph it is I would take my parent function. Hopefully I won't have to fool around with it like I did the other one. So here's my parent. I've moved right 4, so this now moves over 4. And all my other points are going to move over 4. So I go from 1, 1 to 5, 1, which is here. And it's reflected over the x-axis, so I'm going to put them on the other side of the x-axis. And then I go from 4, 2 to 8, 2, which is here. And then lastly, I go from 9, 3 is going to be 13, 3, which is kind of out of the picture. So I can use my parent function points to graph this. The other option is just use a table of values. You're going to get the same picture anyway. Okay, here's one for you to try. Then I'm going to move on to the next thing we're going to do, or last thing we're going to do. Use the description to write the square root function. The parent function f of x equals square root is reflected across the x-axis, compressed vertically by a factor of 1/5, and translated down 5 units. So reflection across the x-axis, this is a vertical vertical reflection. So I know that that's going to look like this. Okay, vertically compressed by 1/5. So that's my A. So that means I'm going to now have f of x equals a negative 1/5. Vertical changes are outside the square root function. And then translated down 5 units, again, that's not going to go inside the square root function. So it's going to be f of x equals a negative, I don't know why I keep forgetting that. Negative 1/5 square root of x plus 5, where 5 is not underneath the radical sign. Oh, sorry, it's down, so it should be minus 5. And that would be your final equation. All right, so there's one for you to try. See, make sure you can. So it's reflected across the x-axis, stretched vertically by a factor of 2, and translated 1 unit up. See if you can write that function. And that concludes this lesson. Here is the homework. Bring any questions to class.